Yeah, so there are some question in exam also, okay, similar to that. Again, they have given graph and then they have asked what is the Fourier transform of it, okay. Yeah, like that, okay. First you should able to grab what is that function, okay. If they mention function in terms of graph, you should able to write that function, okay. Yeah, Dirac delta and properties. Dirac delta not function, okay. We better call it as Dirac delta distribution. It's not a ordinary function which we use in mathematics, okay. So because look at here, I hope you know something about it. So Dirac delta by Dirac delta distribution, or sometimes we say function also, okay. But the mathematically that function should satisfy something, am I right? It should be very well defined in its domain, isn't it? It should not touch infinity and all, okay. So now Dirac delta is defined like this: delta of x is equal to infinity when x equal to 0, okay, 0 when x not equal to 0. Not only like that, look at here, Dirac delta, along with that one, integral minus infinity plus infinity, delta of x into dx, this is equal to 1. Actually, what they do is, they directly define Dirac delta like this, okay, and they say delta of x is equal to 0 when x not equal to 0. They don't write this one, okay. I mean, if you see Dirac book, I mean, very original text actually, you will not see of writing infinity. He will mention this one, okay. He will mention this one. It's equal to 0 when x not equal to 0, okay. And it is non-zero when x equal to 0, okay. To make this area under the curve 1, its height should be very high actually. Are you getting my point? If you, so again, this function is 0 here, okay. When x not equal to 0, it is 0 here. But area under the curve is 1, am I right? Are you getting my point? So to make that area under the curve 1, at 0, you should have peak, I mean, of very high value. Is that okay? Later we define like this for our comfortness, because writing this infinity is not a good deal actually mathematically.
High value means?
Look at here. So just take only these two. I said delta of x is 0 other than any 0 value. Okay. When x not equal to 0, it is 0. But total area under the curve is 1. I'm saying like that. Am I right? Function is 0. Okay, when x not equal to 0, but area under that function is equal to 1. To make that area 1, you should make this one kind of spike here, isn't it? Of infinite height, because you are making width 0, isn't it? You are making this width almost 0. Am I right? It is equal to 0 when x not equal to 0. The x not equal to 0 means when x is greater than 0, when x is less than 0, it is 0. At x equal to 0, it is non-zero, okay? This is the actual definition actually. Later we write like this. Are you getting my point? Speak out.
So this is a point function?
You can say like that. It's not a function actually.
Singularity.
Yeah, it has a singularity. We say like that, but we again they avoid this one in the beginning stage. They avoid writing this one. This is for our comfort actually. Is that okay? So what they say is it's equal to 0 other than x equal to 0. Function is 0 everywhere except at x equal to 0. Can I say like this? Function is 0 except at x equal to 0 and area under the function equal to 1. To make that area 1, look at here. If you draw a very small area, isn't it? You are making this width 0 if this height is finite. Okay? So 0 into some finite value, that would be 0 only, but you are making this one finite, am I right? That's why this height should be very, so that this area under the curve should be 1 actually. Are you getting my point? It should be finite.
So what's the importance of this?
No, again, importance comes when you apply that one, okay? So from the application only, from the necessity in the application, they started defining this function. This is not mathematically well-behaved function at all. Is that okay?
No, sir, electrodynamics, one question is direction.
Yeah, so again, everywhere, again, we use this one. So from the what you call, it's a kind of necessity of defining this kind of function, but mathematically it's not well-behaved function. Speak out. Now wait a second. Again, this is called as distribution because look at here again. If you want to define it mathematically, delta of x should be defined like this: limit a tends to 0. Okay, 1 by a root phi e power minus a square by x square. Sorry, x square by a square. Because again, any distribution that can touch infinity, am I right? There is no harm. But well-behaved function should not touch infinity, isn't it? So mathematically, it is defined from the Gaussian actually. I mean, if you want to touch this one to mathematics, okay? Look at here, this area under the curve is 1. This is a normalization constant. This area under curve of this function is 1 actually. You can check that out. Then what we do is we make a tends to 0. If we make a tends to 0, look at here. So 1 by a square, that's very big factor. Okay? That means Gaussian will drop very quickly. Isn't it? So take Gaussian. Okay? Take this coefficient very high and take this one, this multiplicative factor very high when a tends to 0, so that this will go, this peak will go above and this width will decrease actually. Then it will become Dirac delta. Speak out. So what I am saying is, initially they defined it like this, okay? Later, for our comfort, we are writing at x equal to 0, you should go to infinity, so that since width is almost 0, height should be infinity, so that area under the curve is 1. That is the argument. Is that okay?
Yes. Sir,
Yes, speak out.
the function of limit a tends to 0 and then the bracket 1 by a root by e power minus x square by square.
Yeah.
When a tends to 0, then the delta function becomes 0.
No, not like that. Look at here. So just check out, try to plot this one in your GeoGebra, okay? So what will happen is this width becomes so thin and this height will go to infinity, isn't it, when a tends to 0. So because when this coefficient 1 by a square, when a tends to 0, when this coefficient is high, it will try to fall off quickly to 0, okay? Just check that out. So tomorrow let me try to give some what you call idea using GeoGebra, okay? That will give you more idea, okay? So that's why, remember, this is for our comfort. This is the actual definition of Dirac delta. Without this one, the definition of Dirac delta is meaningless. Without this integral, without saying that integral over all range equal to 1, that definition would be meaningless. Are you getting my point? Speak out. Is that okay? Yeah. Yeah, anyway, you will get this in, suppose if you search in Wikipedia, you will get this one, okay, this idea. So that's why it's better to call it as a distribution rather than a function, because it's not mathematically well-behaved function. So necessity in many physical aspect led us to define this one actually. Is that okay? Yeah. Now suppose if you have, and one thing you can observe, look at here, since Dirac delta is a even function, okay, delta of minus x is equal to delta of x. Is that okay? Because it's a Gaussian taken some limit, am I right? Gaussian is even function. You can say like that, okay? So one more thing you can observe. Observation, isn't it? Once it's a limit to some Gaussian, means Gaussian is even function, this should be even function. Is that okay? Yeah. So next one is, look at here, if delta of x minus a, that's equal to infinity when x equal to a, that's equal to 0 otherwise. Is that okay? So now look at here. So again, this, if you define it like this, it is incomplete if you are not writing this one. Is that okay? And one more thing, what we do in the most of the case, okay, we make this one as dimensionless, okay, this right hand side dimensionless, so that again this Dirac delta will have reciprocal dimension as that of this x actually. X can be anything actually, okay. Here we have taken pure mathematical idea, okay. Okay, usually it will have dimension which is reciprocal of that of this x, okay. Can you note that down shortly? Delta x usually have dimension which is reciprocal of dimension of x. Okay, just have a short note on it, because these properties are required to solve the problem. Lots of problems are there. Okay, and one more thing. Okay, you don't have to integrate over minus infinity to plus infinity here. Okay, you can just integrate in the neighborhood of 0. That's also sufficient, because function itself is 0. Okay, but usually we write like this.
Reciprocal of dimension of
X, delta of x, usually this delta of x into x, we want to make this one dimensionless always. Okay, again, if you check out some application, then only you will get some idea. Okay.
Sir,
Yes.
so we can say that it is a normalized function.
Yeah, normalized distribution, not wave function. Okay, normalized distribution, the kind of probability distribution. Area under the probability distribution is always 1, am I right? Area under mod psi square, kind of normalized distribution. Yeah, normalized distribution. Okay. Now, one more very special property of Dirac delta is, if you multiply f of x to delta of x, okay, you will get f of 0. Dirac delta will choose the function at that point. Actually, they don't define this one initially. Wait a second, they define this one very later. Let me go step by step. Okay, integral minus infinity to plus infinity. Okay, these are the properties. Okay, these are the property. Let me write in star. Okay, minus infinity to plus infinity, f of x into delta of x dx. Okay, this is equal to f of 0, or if I write minus infinity to plus infinity, f of x into delta of x minus a dx, this is equal to f of a. Okay, sometimes we say this Dirac delta lives inside the integral. Okay, outside integral quite difficult to define and understand that. Okay, lives inside the integral actually.
So to observe this function.
Now wait a second, we shall see what is this property. So here this Dirac delta is spike at x equal to 0, am I right? So that's why Dirac delta will choose the function at the point where it is spike. Can I say like this? Because this is spike at x equal to a. Delta of x minus a. How do you draw this one? Suppose a is positive here. You should draw a spike at x equal to a. Because at x equal to a it is infinity. It is 0 otherwise, isn't it? That's how it is defined. So that's why. So this is delta of x. Can I write like this? This is delta of x. This is delta of x minus a. Now this definition says Dirac delta will choose the function at the point where it is spike. Can I say like this? And in this one, you don't have to integrate this one from minus infinity to plus infinity. You can just integrate in the neighborhood of a. You can just integrate in the neighborhood of a. What we write, a minus epsilon to a plus epsilon. Epsilon is positive. You don't have to integrate here also. You don't have to put minus infinity to plus infinity actually. You can just integrate in the neighborhood of 0 to get area under the curve, isn't it? Because outside that region, isn't it? Other than at x equal to a, this function itself is 0, am I right? Our integral is 0, again, other than at x equal to a, by the definition of Dirac delta, isn't it? Speak out.
No, this infinity is about comparison, right?
No, again, since it is a Gaussian, taken some limit, that Gaussian range is minus infinity to plus infinity. That's why in the basic definition they take minus infinity to plus infinity, but it need not be minus infinity to plus infinity. It need not be, because this is 0 other than x equal to a. Observe that one. Should I write this one again? Delta of x minus a, that's equal to infinity at x equal to a, 0 otherwise, isn't it? So that's why you just have to integrate in the neighborhood of a where delta, again, Dirac delta is non-zero.
Sir,
So wait a second. F of x into delta of x minus a dx is equal to f of a. This is also true. You just have to integrate in the neighborhood of A. Okay? If you integrate in some other region, okay, suppose you have x equal to A here, x equal to A here. If you are integrating in some other region, okay, then this integral is 0 because Dirac delta is 0, isn't it? Is that okay? Where epsilon is a positive quantity, okay? Dirac delta will choose the function at the point where it is spiked. It will choose the function at the point where it is spiked, f of A, isn't it? This is function, x is variable, am I right? It is giving you the value of the function at x equal to A. Isn't
So
it?
here A minus A limit and A plus epsilon is limits of what does represent these limits of
I'm just integrating in the neighborhood of A. Again, so A minus epsilon here, A plus epsilon here. Epsilon can be very small also, but epsilon should be positive. So I mean, it need not be minus infinity to plus infinity. It should be neighborhood of that one. Suppose if I integrate, look at here, A plus epsilon to A plus 2 epsilon. What is this one? Can you tell me? If you have x equal to A here, you have A plus epsilon here, A plus 2 epsilon here. You are integrating your function in this region. What is this one now? You are integrating other than the region at x equal to A. It should be 0, okay? Because your Dirac delta is 0 there. Is that okay?
It should be symmetric, the limit.
Yeah, if your limit covers x equal to A, then only this property is true. And it need not be minus infinity to plus infinity. Is that okay? Your limit of the integral should cover entire A.
No, sir, we are at first we are considering infinity plus infinity. But right now we are.
No, that is not required. That's what I'm saying. Here also it's not required. Look at here. Again, what you want to say, total area under the curve equal to 1. Am I right? You just integrate in the neighborhood of A. That's sufficient. Since it is a Gaussian, it was a Gaussian and taken some limit, isn't it? Gaussian, what is the range? Minus infinity to plus infinity. Am I right? That's why we put like that. But it is not required because, so this is 0 outside x equal to 0. You just have to integrate in the neighborhood. Neighborhood, do you know that one mathematically? Neighborhood means 0 plus epsilon, 0 minus epsilon. Epsilon is very small. That's how we define neighborhood. Is that okay?
The respect of wave function, the Gaussian wave function,
Gaussian function taken some limit. That's why your integral should be minus infinity to plus infinity, because Gaussian have the range minus infinity to plus infinity, isn't it? Yeah, like that. Is that okay? I hope you got this idea. If your limit of the integral is not covering at x equal to A, it's not covering that x equal to A, so then it is 0. Is that okay? Speak out. It need not be symmetric also, okay? It can be asymmetric also. I have taken A minus epsilon, A plus epsilon. Symmetric limit, am I right? About x equal to A.
So the symmetry will be 0, sir.
Suppose, let me take, this is from x1 to x2, okay? F of x. Don't talk about symmetry or antisymmetry. Wait a second, sorry. Okay? It is equal to f of A if A is between x1 to x2. 0 otherwise. Can I say like this? If your limit, if A is in between this limit, okay, then only it is f of A. It is 0 otherwise. Is that okay? That's the best way to define that one. So delta of another property A into x, okay, that's equal to 1 by mod A into delta of x, another property, okay. And one more thing, we define a function, we call this as unit step function, okay, theta of x. It's equal to 1 when x is greater than 0, it's equal to 0 when x is less than 0. If you try to plot this one, it will look like this. Theta of x it's equal to 0 here, it's equal to 1 here. Is that okay? Unit step function, we say like that. Okay? Now, Dirac delta is also defined as derivative of unit step function.
Scaling property.
No, not, you can say scaling property. Yeah. Look at here. Dirac delta. What will happen here when you take derivative? Derivative of constant 0, am I right? Derivative is 0 here, derivative is 0 here. But at this point, your derivative have very high value, am I right? As x is changing, again, so this delta theta by delta x, this is very high at this point, isn't it? Or you can say slope is almost infinity. Slope at this point to the curve is almost infinite. You can say like that, isn't it? That's why Dirac delta is defined like this. Obviously, this also gives the same thing, am I right? Derivative is 0, constant function derivative 0. Constant function derivative 0. But at this point, derivative is non-zero because it is suddenly changing, am I right? You should have, what does derivative says? How much it is changing when this is changed by very small value. It is changing.
Sir, how can you relate the slope here?
No, again, so here slope is 0, here slope is 0, here slope is almost infinity. You can think like that. That's what I'm saying. Is that okay? So that's why Dirac delta is a derivative of unit step function. This is another definition. I want to prove this one, okay, because this kind of ideas may help us actually. This kind of idea may help us. Integral minus epsilon to plus epsilon, okay, f of x into d theta by dx into dx, okay. Is that okay? So then I'll do integration by parts. F of x into theta, first function into integration of second function, minus epsilon to plus epsilon. Isn't it? Can I write like this? Minus integral of, so theta into theta of x into f of x dx. Can I say like this? Okay. So by the definition of theta, at minus epsilon, theta equal to 0. Epsilon is positive, minus epsilon is negative. Okay, theta is 0, that's why it is 0. At plus epsilon, theta equal to 1, that's why it is f of epsilon actually. I just substitute, you will understand. So take the definition of theta. Theta is 0 at x less than 0. That's why 0 into anything, that is 0. So when it is positive, theta is 1 multiplied is f of x, f of epsilon, okay, minus, look at here carefully. Theta is 0 when x is less than 0, that's why this will become 0 to epsilon. And theta again, so take the definition of theta, isn't it? It's a piecewise function. It's a piecewise function. You have to convert into minus epsilon to 0, 0 to epsilon, minus epsilon to 0, theta equal to 0. That's why only 0 to epsilon remains 1 into f. Wait a second. What is the mistake? Derivative of second function. Am I right? Isn't it? Integration by parts. Okay. Into df by dx into dx. Okay. Check this out. F of epsilon minus derivative of integration, that is f of x running from 0 to epsilon. So f of epsilon minus f of epsilon plus f of 0 is equal to f of 0. What I have done is, look at here, this one, I have proved this one as f of 0. That's why this should be Dirac delta. You can say like that also, because Dirac delta behaves very well inside the integral. Okay, whatever the proof you want to show, you should go for integral and then you have to show. That's why this is delta of x. That's a property, isn't it? Earlier property. one more property, because these kind of questions are there. Okay, that's why I'm discussing properties properly. Integral delta of a minus x, okay, into dx delta of x minus b is equal to delta of a minus b. We shall try to prove this one, because one question is there in CSIR, quite confusing. That may help us. Okay, this proof may help us. Okay, in solving that question. Okay. What I do here is I'm going to take one double integral kind of thing. Okay, this is a kind of double integral. F of a into dA, or a doesn't look, yeah, f of a into dA. Let me take f as a function of a, okay, into dA. I'm integrating with respect to dA, just like f of x into dx. Okay. Then I'm going to multiply with this one, integral of delta of a minus x dx delta of x minus b. Okay. Let me take this integral. It's a kind of double integral. Okay, where I made this a as a variable here. Okay. Now again, the order of integration doesn't matter. Am I right? Always order of integration doesn't matter. That's why what I do here is I'm going to take delta of x minus b into dx one side. First I will do delta of a minus x into f of a into dA. I'll do this integral first. Later I'll substitute and I'll do this integral. Now it's a kind of trick. Okay, delta of x minus b dx. Look at here. This is integral with respect to a. A is variable here in this integral. Okay. If you apply property of Dirac delta, it will choose the function at a equal to x. Can I say like this? So that's why this will be f of x. This one. Because a is, yeah, exactly reverse. Okay. Here a is variable, x is constant. You should imagine like that. Is that okay? Delta of x minus a, you have a minus x. In place of x, you have a. Exactly. Same, very similar integral. Delta x minus a f of x dx. What we have written? F of a. Am I right? A and x are interchanged in this equation, nothing else. Okay. In this equation, a and x are interchanged. You will get here. Okay. Now what will happen here is, look at here. So this is integral with respect to x. Now it will choose it at b. Am I right? Can I write f of b? Or I'll not write it as f of b. Look at here. What I'm going to do here is I'll change x to a again. In the next step, I'm going to change x to a. I'll replace x by a. It doesn't matter. Am I right? Which variable you take, which symbol you take. So that's why this will be delta of a minus b into f of a into dx. A again, x should be changed by b. Am I right? dA f of a. Now look at this one. This is equal to this one. So from here to here, what I have done? Change x to x by a. Is that it? X is replaced by a. Now this is equal to this one. Am I right? Check this out. F of a is there. dA is there. Integral with respect to dA is there. Wait a second. F of a is there. Yes. This. Speak out.
These are integration part. Sir, last term, not the integration part.
No, there is no integration by parts here. Again, I'm from here to here. I'm just replacing this symbol x by symbol a. I got this one. Here to here, I got symbol x, which is replaced by symbol a. That's what I'm saying. Is that okay? So now look at these two. F of a dA is there. F of a dA is there. Integral with respect to dA. Integral with respect to dA. Whatever this part, this should be equal to this part. That's what this says. So try to do it yourself, because I think it is required in one of the problem. Okay, this derivation is required in one of the problem. Try to do this one. It's a kind of tricky steps. Okay, so taking this integral and changing the order of the integration, and again writing using property, and again changing the symbol, and comparing initial integral and final integral. So this whole thing should be equal to delta of a minus b. So that's what I have written here. Okay, or if you can't do this one, just remember this one, that property may be needed further. Okay.
Sir?
Yes. Now, one more very important property. Let me take minus infinity to plus infinity for to be in the safer side. F of x into d delta by dx. Okay, into dx. So can I write this one as delta prime? Delta prime. You know that symbol, derivative symbol, because in all book they take like this. Okay, delta prime of x, that means first derivative. Okay, so that's equal to minus integral minus infinity to plus infinity. Okay, f prime of x into delta of x dx. F prime means first derivative of f of x with respect to x. Okay, that means derivative transform to the function with one negative sign. Look at here, this is how I remember. Okay, derivative will transform to the function, derivative on the Dirac delta transform to the function with one negative sign. If you had second derivative dx, that minus 1 will transform twice. F double prime of x delta of x dx. Can I write like this? Second derivative of f, second derivative of Dirac delta. Can you see this one on Google Meet clearly?
Yes, sir.
Yeah.
Yes, sir.
So similarly, f of x into nth derivative delta n of x. Okay, nth derivative, not power. Okay, dx, that's equal to minus 1 power n into integral minus infinity to plus infinity. Okay, nth derivative of f of x into delta of x dx. The derivative will transform to the function with one negative sign. So that's the best way to remember. You need to solve some problem, okay, before tomorrow. It's a good idea. I mean, maybe 1 hour, it may take 1 hour only. Okay, so you can take these things are properties. Okay, star means property. I mean, these can be proved again using the original definitions. Okay, delta of x square minus a square.
Sir, which book do you use?
I am using many books. You just note this term. Okay, we don't have time now. Okay, delta of x plus a into x minus a, isn't it? Can I write like this? This can be written as 1 by 2 mod a delta of x plus a. There are questions on these properties. Okay, I'll upload this MCQ now after this class. Okay, so similarly, delta of some g of x, some function of x. Okay, this can be some polynomial ax square plus bx plus c, suppose, isn't it? Or any cubic equation, whatever. Okay, so that can be written as, look at here, summation over I, delta of x minus xi. Let me tell you what is this xi, divided by mod of g dash of xi, where xi are the roots of the equation, xi are the roots of the equation g of x is equal to 0. If you equate g of x to 0, okay, you will get some roots, am I right? Suppose if you have written a delta of x minus a, okay, that means you put first x minus a equal to 0, am I right? Then you find x equal to a, that is the point where it is spike, isn't it? Yeah, I kept look at here, little bit volume also, okay? Volume is on, screen is on, it is switching off if I am not touching that one after a long time. That means we can't move, we can't watch movie over there, isn't it? You should keep on touching that one. Whatever, isn't it? Some default should be there, isn't it? If something is running. Yeah. Again, I have to search for that setting. Yeah. Where xi are the roots of equation g of x equal to 0. If you equate that one to 0, you will get the value of this g of x where it is 0, isn't it? Can I say like this? Xi are the value of x where this one is 0. Suppose if you have written delta of x minus a, okay, x equal to a is value of this x minus a, where x minus a is 0, isn't it? Yeah. Let me take one example. So example, delta of x square plus x minus 2. What is g of x here? X square plus x minus 2. What is this one? How do you write x plus 2, x minus 1? Okay, x is equal to 1 and minus 2. These are the point where your g of x is 0, isn't it? Not over. I need g dash of x also, isn't it? This is first derivative. Don't forget. Okay, that's equal to 2x plus 1. Am I right? G dash of 1, that's equal to 3. G dash of minus 2, that's equal to minus 1. Am I right? No, not minus 1. Minus 2 means 4 minus 3. Check this out. Isn't it? So that's why this is written as, okay, delta of x square plus x minus 2. It's a summation. Observe that one. Let me take one of the root. Delta of x minus 1 divided by mod of g dash of 1. Okay, so that's equal to 3 mod 3 plus delta of x minus xi, x minus of minus 2, x plus 2 divided by mod of this one, mod of g dash of minus 2. Don't forget mod plus 3. Later again, if any question comes, you can answer. Am I right? If it is converted into basic definitions, isn't it? You can answer any questions. Let me upload problem. Later I will solve problem, or I'll upload any old video which contains solved problems. Okay, so that you can take the hints. One more very important part here. So tomorrow you will understand the application of this one. Okay, I'll tell what is the Fourier transform of Dirac delta. Let me define Fourier transform like this. F of k is equal to integral minus infinity to plus infinity f of x into e power ikx dx, or let me define it as minus here. It doesn't matter, I told you, isn't it? Whether you take plus ikx or minus ikx, it doesn't matter. Now let me take f of x is equal to delta of x. It's not right to write like this, okay? Because it's not a function, well-behaved function, like any other function in mathematics, okay? So that's why if you take minus infinity to plus infinity, Fourier transform of Dirac delta, e power minus I kx into dx. What is this one? Quickly tell me.
One, sir.
Yeah, this will choose this function at x equal to 0. e power I into 0, that's equal to 1. Now think about inverse Fourier transform. If this is the Fourier transform, how do you write f of x? Speak out. Integral 1 by 2 phi. Or you can put 1 by root 2 phi here, 1 by root 2 phi here, isn't it? Minus infinity to plus infinity. F of k into e power I kx into dk. So that's why this delta of x can be written as 1 by 2 phi, or you can put 1 by root 2 phi, 1 by root 2 phi, okay? There is no harm here. Minus infinity to plus infinity, 1 into e power I kx into dk. Another way of writing Dirac delta. And try to plot this. Okay? This one, f of x equal to 1, am I right? Dirac delta. Delta of x here. F of k, can I write this one as f of k? Can I write it as f of x simply? F of k is equal to 1, it's a constant function. It will help us to understand uncertainty. Well-defined position, am I right? Ill-defined momentum, if you multiply by h bar here, h bar k is the momentum, okay? It will help us to understand. Tomorrow we shall see the physics part of it, okay? Yeah, later I have to discuss some more property of Fourier transform, just like someone asking if k replaced by minus k, what would happen, isn't it? And if you take a complex conjugate of this function, what would happen? If you take derivative of this function, what would happen? There comes the application actually, okay? In solving differential equation, okay? We shall see some more property and its direct application to solve differential equation in the next mathematics class, okay? Yeah, so the direct application of this Fourier transform is in our position space wave function to momentum space wave function, phi of k. Phi of k is called as momentum space wave function, okay? So, but other pure mathematical application we shall see, because there are some questions in exam, very rare, but questions are there on solving partial differential equation. I think you might have seen solving partial differential equation, very old questions actually. Yeah. Yes, tell me.
Sir, here Dirac e power minus I kx minus infinity to plus infinity. Sir, how we choose here? One, sir, is fine, sir.
No, again, this will choose this, take this one as a function, multiplied with Dirac delta. Again, you have written, am I right, f of x into delta of x, something is equal to f of 0, like that, okay? Yeah, wait a second. I forgot one more thing here. F of x into delta of x, just this multiplication is equal. Now, if I write integral minus infinity plus infinity, f of x delta x dx, okay? What I can write? F of x delta x can be written as f of 0 delta x dx. F of 0 is a constant which can be taken outside. Integral delta of x dx, f of 0 integral of delta of x dx. This area under the curve equal to 1, that's why it is f of 0. Now it will make sense, isn't it? If you integrate, this f of a will come outside. Integral over delta of x minus a is 1. That's why that integral is equal to this one. Is that okay? Earlier, whatever I have written, that was wrong, okay? Not only f of 0 into delta of x. F of x into delta of x minus a is equal to f of a into delta of x minus a. Is that okay? Write down these two carefully. Yeah, now it's right. So similarly, look at here. If you have an integration minus infinity plus infinity, f of x into delta of x minus a dx, okay? So that will be equal to integral minus infinity plus infinity f of a into delta of x minus a dx. Am I right? This is equal to this one. That's what I have written here. So f of a is constant. You can take it outside. You can write f of a into integral minus infinity plus infinity delta of x minus a dx. This equal to 1, area under the curve of Dirac delta. That's why this should be equal to f of a. I hope you will remember this property. Very important, okay? Otherwise, you can't understand whatever the step we write in third chapter. It is there in the third chapter.